Hello. So in this video, we're going to talk about geometric transformations, specifically dilations. This is part 3 of a 3-part series on dilations. Part 1, we talked about kind of what is the dilation, how do we do them, and we worked on dilating points. Part 2, we worked on dilating images, and this is part 3, where we're going to actually just be determining the dilation scale factors. So they're going to give us the 2 images, and we need to determine, okay, how was it scaled? But briefly, again, let's review. What is a dilation? Dilation means that our image is getting bigger or smaller. Bigger or smaller. I did that backwards. And this figure is going to retain its original shape and orientation. It's just going to get bigger or smaller. So just a size change. One of the terms, scale factor. And in these videos, we're going to be determining that. So the scale factor is by how much were the distances scaled. So for a dilation, they're going to give you a point of reference, and you need to figure out the x and y distances from the point of reference to the point that you're trying to scale. And then it's going to be, that distance is going to be multiplied by the scale factor, and the new distance is going to be your image. For a scale factor, if our scale factor is greater than 1, our image will get bigger. If our scale factor is between 0 and 1, the image will get smaller. So this will help us as we're trying to determine scale factors, because if our new image is bigger, we're looking for a number that's bigger than 1. If our new image is smaller, we're looking for a scale factor that is between 0 and 1. So let's do some examples. So this first one, this point M has been dilated by some scale factor about point C to become M prime. So what is our reference point? Our reference point is C. So if you remember from the past videos, we're going to set up that table. So first we're going to determine from C to M. C to M. What is the x distance and what is the y distance? Okay, well, let's figure that out. Our x distance is 1, I can't see that, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going 12, positive 12 in the x, and we're going negative now because we're going down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going negative 12 in the y direction. Okay? So now we don't know what our scale factor is. Normally, in our table, we'd write the number, the scale factor, times our x, and the number times our y. We don't know what that is, so I'm going to call it, so what you'll commonly see it as is a k. It can be anything. It can be a k, it can be an n. Doesn't matter, it's scale factor. Okay, so we don't know what that scale factor is. We do know what is from C to M prime. Well, C to M prime is 1, 2, 3, 3 in the x, and 1, 2, 3, negative 3 in the y. So that's C to M prime. Okay, so that's our distances. So now how do we figure out what that k value is? Well, remember, you're going to multiply that k value by your x to equal your new value. So it's k times original x to equal new. So we're going to have k times original x equals new value. Our original x value, we're going to have k times 12. That was our original x value equals 3. So now I have 12k equals 3. Divide both sides by 12. And I get k equals 3/12, or simplified 1/4. Okay, so that's what I'm saying the scale factor is, 1/4. So let's multiply it by the y, and let's make sure that we do get the same answer. So 1/4 times negative 12, well, multiplying by 1/4 is the same thing as dividing by 4. So negative 12 times 1/4, or negative 12 divided by 4, is -3. So this is correct. K is 1/4. That is our scale factor. Okay, so that's for points. The next one we're going to do is for an image. Now, dilating images is just the same as dilating a bunch of points and then connecting them with lines to make an image. So, from here, we say figure BCD was dilated about point B. Oh, cool. They give us a reference point. Awesome. So our reference point is B. So we're going to figure out from B to D, the originals here, B to C, and B to B. Okay? So what are our original X's and Y's? B to D is B to D. 1, 2, 3. -3. And -3, 1, 2, 3. +3. B to C is 1, 3. And B to B is 0, 0. All right, but let's talk about our new here. So our KX, KY, because again, we don't know what the scale factor is. We do know this is going to be B to D prime, B to C prime, and B to B prime, which B to B prime, it didn't move, so 0, 0. And again, that works because K, or any number, times 0 is 0, so we get 0, 0. All right, but B to D prime, B to D prime is 1, 2, 3, 4, 5, 6 is -6, and up 1, 2, 3, 4, 5, 6, up 6. Okay, and B to C prime is 1, 2, +2, up 1, 2, 3, 4, 5, 6, up 6. Okay, so we can take any of these and compare them. So I'm just going to compare the -6 to, so the B to D prime of -6 to the B to D X of -3. So I'm going to have K times X equals -6, or X, which is -3, K times -3 equals -6. Divide both sides by -3, and I get a scale factor of 2. K is 2. So my scale factor is 2. So we have enlarged figure BCD by 2. We made it twice as big. Okay, so let's look at another example. Figure XYZ underwent some dilation to form X prime, Y prime, Z prime. Determine the scale factor. This one, they don't give us a point of reference. They just tell you, hey, we had this image. We made it smaller. Figure it out. Okay. All right, let's think here. So normally we would pick some reference point and base everything off that reference point. Well, in these cases, what you're going to do is your reference point is, like your reference points, I mean, every point is going to become a reference point at some point. So we need to find the distances of these legs. Distances of the legs, or at least the distances between the points of the legs. So all the x, y's. So I'm going to find from x to y. I'm going to find from x to z. And I'm going to find from z to y. All right, from x to y, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I go 12 in the x, 0 in the y. From x to z, I go 1, 2, 3, 4 in the x, and I go 1, 2, 3, 4, -4 in the y. And from z to y, I go 1, 2, 3, 4, 5, 6, 7, 8. I go +8, and I go 1, 2, 3, 4. 4. Okay, now I'm going to look at my scaled version. So kx, ky. So now I'm going to go from x prime to y prime. x prime to z prime to y prime. So from x prime to y prime, I'm going to go, again, 0 in the y, which makes sense. No matter what k is, multiplying by 0, we get 0. And I'm going to have 1, 2, 3, 4, 5, 6, and I have a 6. From x prime to z prime, I'm going to go 1, 2 in the x, and 1, 2, negative 2 in the y. And from z prime to y prime, I'm going to have 1, 2, 3, 4 in the x, and 1, 2 in the y. So again, I can pick any of these, work out the equation. So again, I'll just do the first ones. So I'm going to have k times x equals 6. I will have k times 12 equals 6. Divide both sides by 12. I will have k equaling 1/2. Okay, so now hold on. You may be thinking, oh, we're done. We need to make sure that that scale factor holds for all of these. Because if it doesn't, then this wasn't properly dilated, and we don't technically have a dilation. Now, it does say it underwent a dilation. Let's make sure they did it right. You might not have done it right. So 1/2. 1/2 times 12, you get 6. 1/2 times 0, 0. X prime to y prime works. 1/2 times 4, 2. 1/2 times negative 4, negative 2. X prime to z prime works. 1/2 times 8, 4. 1/2 times 4, 2. Z prime to y prime works. So their dilation is correct, and our scale factor is 1/2. Now, you might be thinking, hey, that was a fraction. How did she multiply that so quickly? Multiplying by 1/2 is the same thing as dividing by 2. Remember that. That's going to come in a lot of help. Very handy later on. So multiplying by 1/2 is the same thing as dividing by 2. 12 divided by 2, 6. 8 divided by 2, 4. 8 times 1/2, 12 times 1/2. Okay, so just helpful hint there. All right, so I hope that these videos have cleared up your dilations questions. If you are seeking more math help, please subscribe to my YouTube channel. There are going to be lots of videos on there that'll be helpful. Or if you have a very specific question, specifically about the video, visit my website and go to the contact page and submit your question via the submission form, and I'd be happy to get back with you. Thank you for watching.